Yeah, good day, ladies and gentlemen. Today's tutorial, I'm going to teach us ANOVA analysis. So when we're talking about ANOVA analysis, it's a statistical test used to determine if there is significant difference between the means. So and also when we're talking about ANOVA itself, focusing on variance, that's why we used to call it analysis of variance. And when we're talking about variance is dealing with the standard deviation, where we before you can get standard deviation of any value, you have to find the means. So and the means of your like any kind of data set given to you is called variance. So that means ANOVA itself focus on means of two or more groups of data set. It's work by partitioning the total variance of data into different sources of variation. So it allows you to compare group means while counting for what for within the group. So and also we have a partitional variance, we have under partitional variance we have ANOVA between the group, ANOVA within the group, and also F test and null hypothesis calculation results. So if you get these are the steps we are going to follow. So we are going to determine your test, maybe the ANOVA you are working with. So you are going to get it, maybe it's not hypothesis or it's alternative hypothesis. You are going to prescribe the hypothesis for your data. So and after that you are going to interpret your results. So interpreting your results based on the result you get on your F statistic or normal critical value you get from your table. So in the F statistics is the calculation you calculate from all the things. Maybe you do normal manual calculation like this, so using this formula. So source of variation, sum of the square and the this is the table for ANOVA. So under this table we make use of this table to arrange all our calculations that we have done so far in analyzing our data. So and then this one SSW, so you are going to use to like calculate the sum of the total set of the variable you have. Maybe you have 1, 2, 3, 4, 5. So I'm going to do a video that is going to like calculate the manner, but today I'm going to use Excel to do all the calculations instead of you doing it one by one. So just use Excel. How to use Excel to do all these calculations, and you are going to input the value into it without stressing yourself. So now let's use Excel to do this table, and it's going to give us this answer immediately after we finish the analysis. So let me open my data. So let's say we have this data, we have all these data sets group by group. We have group A, we have group B, we have group C. So and they say that you find an ANOVA of analysis of this table. So let's say we want to find let's say we want to find the single factors ANOVA. That is one-way ANOVA. So if you want to find this one, how can you get it? So in Excel, before you go to this analysis, you are going to import data analysis tools in your Excel first, where you go to file here at the top. When you get to file, you click on options. So under the options, it's going to open a tab for you. So then you come here under the add-ins. When you click on add-ins, then you click OK. So if you click OK, it's going to open a tab for you. Let me wait a bit. So when you open that tab, from there, so gonna add data analysis for the top of your data here. So which is still loading. Okay, let me click on option, then go. Still coming up. Yes, okay, that's coming up. So when you click on this now, let's click on the add-ins. Excel add-ins. So you click on go. So you click on go, you will see something like this analysis ToolPak. So make sure you mark this. After you mark it very well, so then click OK. So when you click OK, it's going to brought up the data analysis here at the top. When you check the data ribbon, you are going to see data analysis here at the top. So if you don't see it there, so just go through that process, you are going to see it here. So now after you have seen this one there, so now the work is a little bit done. So what you are going to do is just to highlight your work like this. After you highlight your data set, so based on the data set given to you, but ANOVA data set always to be in group. can be group 1, group 2, group 3. So if it's single factors, you'll be in group. So now after that, you want to find the ANOVA analysis of this one-way ANOVA of this one. So what you are going to do is just to come up a little bit here, then click on the ANOVA single factor. So then you click OK. So now you are going to select the range, the input range. So you select everything here. So that's selected. So what I'm going to do here, under the alpha, make sure that your alpha is 0.05. so that is a significant level of your data set. Is always 0.05. so, and we use that 0.05 to identify that even if your data set is not up 100% accurate, so if 100% accurate, there will be 0.5 errors out of it. And that's what we mean by data analysis. What we are talking about when we are talking about data itself, data is model plus error. So if model is not with error, that means it's not real data. So a data always defined as model plus error. So now the error that we are going to maybe actually have in our alpha hard things can be 0.05. that is 5% out of this. That is a significant level of your data set. If you now have any data set that is low, let's say it's lower than that, it's not good. It's like the data is not really, it's very poor for your analysis. So it can give you a model from let's say alpha level of significant level that you are going to get, that even though it can like give you a little bit of assurance that this analysis that I've done so far, so it's 99% accurate. And from there you can have a confidence, that's what we call and we have confidence interval, confidence level. So that's when you have confidence in your data set that this with this a little 0.05 level of significant that I was able to prescribe that this data is so things, this data is so things with all the data sets you have compiled together. You can be bold enough to say that with all these things that I've read, the model that I prescribed for this data set is accurate. So it's accurate with this. So now after you click on this, I've selected the table. Now let's click OK. So if you click OK, it's going to show it for you here. So this is your result. This is the ANOVA or single factor. And if you check your table here too as well, you will see that everything that is there is almost here too as well. So the only thing you are going to do is just to fit in the value you got here into that table. So fit it in there. So that's how to got our answer. So you see group 1, you calculate the count of it. If you count the list of everything that is here from here to this part is 10. So we count the count of it to be 10, then sum it together. So this is the adding sum of it. So now and then the average of it is this, and the variance. So that means the square root of the average is what you have here. So now after you got that, you do for B, you do for C too as well. So with this one we have between, if you see the table that I show you earlier, you see the table, you see the this one, that is sum of the square within. So this is sum of the square within, and if you see this one too, we have the sum of the square within, between the group and also within the group. So these are the values that we are going to insert into those tables, and you see that in this data set we have a critical value of 3.3541315, and the p value is 0.0. and if your critical value is greater than your p value, that shows that there is a significant difference between the data set. So then we fail to reject the null hypothesis. But if your critical value is lower than p value, so that means it's a little lower than p value, that means you will reject that means you fail to reject the null hypothesis. If your critical value is greater than the p value, you fail to reject a null hypothesis. But if your p value is now, let's say, is greater than your this one, f critical, that's your calculation value. So if it's greater than that, that means you accept the null hypothesis. So that means we let's say let me put in the way that you can be able to understand it very well. That means you accept, instead of you say that you like you reject, you fail to reject it, you just do that we accept the null hypothesis, or we fail to reject the null hypothesis. So we fail to reject the null hypothesis. That's it. So that's how to put it. Then you, after you record that for your distance, then you are going to get the total value here, and everything that you need for your table is out here. So for the two-way ANOVA 2, when you come here to this part 2, let's click on this data set, so and perform two-way ANOVA. So you click on this one and click on the data set here, you click on the two-way, so then click OK. So make sure you select the range. After you select the range, then you put the one value there. So and for this one, you put you select the part where you want your answer to be seen. So let's choose that part and click OK. So it's going to show you the answer for the two-way ANOVA 2 for the table and everything. So this is your answer here, the last part here. This is your table, this is your result, this is what you are going to make use of. So to face into your table. So you see that the p-value here is not calculated, so that there is error in our data set. So but if your data set and everything is accurate, it's going to calculate everything for you, and you are going to see the results very clear and bold. So that's how to go about using Excel to calculate ANOVA analysis. So thank you so much for watching. Please like and subscribe to my YouTube channel for more videos.